Hello class, today we are going to introduce graphs of exponential functions. Now what an exponential function is, that's something where the variable is in the exponents, so something like 3 to the x or 5 to the x or something like that. So let's take a look at the graphs of these. There's two kinds. We have exponential growth and exponential decay. The first one we're going to look at is exponential growth. And this is a parent function for exponential growth. They're all slightly different depending on what the base is. So a function is f of x equals b to the x. And for an exponential growth function, the b, or base, is going to be greater than 1. And on these, they will all have the same general shape, but they might be steeper or less steep depending on what this base is. But they will all pass through the point 0, 1, because that means that would be when x is 0, so when you have an exponent of 0, then it equals 1, and anything raised to the 0 power is 1. So they'll all go through the point 0, 1, and they will also go through the point 1b, because when x is 1, we have b to the 1. It doesn't matter what b is, anything to the first power is itself. So there's that. Alright, and they'll go up like this. And it's going to get bigger and bigger and bigger really fast. And so that's why we call it growth, because it's going to increase. Now, if you'll notice on the left here, the curve is getting very close to the x-axis, but it never actually touches it. Alright, and this is called an asymptote. It gets very, 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 very close to the line. It keeps getting closer and keeps getting closer, but it never actually gets all the way there. Now, the domain for exponential growth is all real numbers, because it's going to go forever to the left. It's going to go forever to the right. The range is y is greater than 0, not greater than or equal to 0, because it's never going to touch that axis. And here we have exponential decay, which you'll notice the graph is just a reflection over the y-axis. This one, the graph is decreasing, which is why we call it decay. It has the same basic form, f of x equals b to the x, only this time b is between 0 and 1. And that's important. B will never be negative. That does really weird things. And we may talk about those in a later date. But this, with b is less than 1 and greater than 0, we're going to have exponential decay. Notice it still goes to the point 0, 1. It also still goes to the point 1b. That doesn't change. It's just that this time b is less than 1, so we're going down. So we have decreasing function, so it's exponential decay. Have the same asymptote. It's still not going to touch that x-axis. It's going to get really close to it, but it's never going to actually touch it. Has the same domain of all real numbers, and the range is still y is greater than 0, not equal to. So let's take a look at a couple of these. What we want to do is we want to look at a and b here, and we want to tell, will this be exponential growth or exponential decay, and then we're going to graph the function. So on a, y equals 2 to the x. Well, our base is 2. 2 is greater than 1, so this is going to be exponential growth. Now, to graph the function, what we're going to do is we're just going to make a table. So we have 2 to the 0, only anything to the 0 is 1. 2 to the first is 2. 2 squared is 4. When x is 3, we have 2 cubed, which would be 8. And then when x is negative, we have the reciprocals of those. So 1/2, 1 over 4, negative 3 would be 1 over 2 cubed. Take that, plot them on the graph, and we see that increasing curve. Make sure when you connect these, you connect it with a nice smooth curve. Don't make it all jagged lines and stuff. Alright. B, y equals 1/2 to the x. Here our base is 1/2. 1/2 is between 0 and 1, so this is going to be exponential decay. Make a table of values. Once you see their base is just the reciprocals of those up there. And we plot the points. And we see this is decreasing. Goes to the point 0, 1. Also goes to the point 1, 1/2 there. notice it gets very close to 0, but it never actually reaches it, because it doesn't matter what this exponent is, no matter how big this gets, it's never going to make the function equal 0. Same thing over here, no matter how small this is, it's never going to actually equal 0. All right. So what I want you to do is work out these 4. I want you to pause the video, find out if it's exponential growth or decay. Do that before you graph it. Then graph it and check it, see if you came up with what you thought you were. All right? And so pause the video, work them out, then come back. All right, so you're back. Let's see how you did. Number 1, our base is 4, which is greater than 1, so this is exponential growth. Number 2, our base is 2/3, which is less than 1, so we have exponential decay. Number 3, our base is 0.25, so we got a 4th there, and so that's less than 1, exponential decay. And on number 4, we have a base of 1.5, which is greater than 1, so exponential growth. And that is basically it for the graphs. This is just a nice introduction. Let you see the difference between exponential growth and exponential decay. Hopefully you found that useful, and I will see you next time.